Good evening. Good evening. Mathematical formula on worksheet. In relevance to that, there are some shapes on drawing format. And title of this talk is Mathematical Formula, Demonstration, Equations, Geometry, Shapes, Combination of Shapes, like January 2nd, 2021, Combinations and Lattice Drawing. Before taking up further details of shapes, or you can say letters and something else, how these have been composed on drawings, that's also relevant to this Excel or Lotus or worksheet. Derivation of formulas, because it's difficult sometimes to show on Excel or worksheet details of this formula, so I like to share it prior to conducting conversation on those diagrams or figures or sketches, you can say, that have been copied from drawing sheet to worksheet for composition of formulas, because composition of formulas is very complicated in certain cases. So I decided to share some drawings with you for that purpose. That is very important. I like to share those drawings with you so that you know how work has been done. I will show you many drawings, not one. These drawings are actual drawings, means model. These drawings are on model format without any scale and direct measurements, because it is on drawing format. ZWCAD I use for this, and not AutoCAD, but it is same, functionally it is same, no difference. This is, which you can see now, this is, this is, you can see has 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. You can see this is letter 1 as I designed this way, means it's having parametric dimension, not actual dimensions. Parametric, I'm to say variable dimensions. Just like I used A as strip dimension, strip width. And when I say strip, this is strip here. This is strip here. For example, this is A, width of strip is constant everywhere in this letter. This is A, this is 3A proportional, and this is 7A, and this one is A. So total is 8A by 5A, and here is 3. I marked area numbers as area 1, 2, and 3. When we use on this A, I give certain number to this on where I work out formula, and that number I usually keep 10. It can be whatever you wish. It is not necessary to be 10, it can be 2, it can be 5, it can be 1, or it can be 1000, as you wish, whatever it is. There's no compulsion on this. So once you keep this cell in Excel open, A is editable, and other all, whatever you compose shall not be editable except where a variable is required. So A produces all these dimensions according to area. This is one part. Now, because this is all rectangular, it's not been very problematic. We can say area is like this into this, or this into this, or this dimension into this, whatever way, and then we can say parameter like this. So you form a standard pattern, just change this and everything else shall change automatically. You know how worksheet performs. Now difficulty comes when we don't have rectangular shape or square shape or trapezoidal shape. when there's arc or curve, whatever is there, it causes concern for purpose of composition of formula, because we have to form with constitute relation between A and all other dimensions, rectangular dimension, square dimension, trapezoidal dimension, triangular dimension, do not pose that type of problems as these curves pose. For example, this curve. This looks something like, it is circular, though not full circle. It's not full circle, but it's circle. So we know formula of circle, either pi r square is its area formula, or you can say pi r is circumference formula. Pi r or pi d, 2 pi r, sorry. And pi, depending on whether it is full circle or it's part circle, here it's part circle. So let's say we count like this, and it goes here and goes like this. Shape is before you can see. Now I say 8A, this I use 8A here, and I use some dimension here. I think I forgot right here. Doesn't matter, I can just say how much is that. It is, it is here to here. It is 5A, so we can say, I can say it's 5 here. Maybe it was written somewhere, but it missed. No problem. We can say this is 5A. So this is 5A, right? So this is 5A by 8A dimension here. Now this was drawn according to how I think it is. Now here is 5A and this is A. As 10 I said A. I actually kept 10, so I put 10, and this is A actually, and this is 8A. And just for clarification, I can say let us put this also A, so that there is no confusion at all. And I say, okay, this is A, and let us say this is, this is A, and this is deleted. So this is A, and we say this is our unit of measurement here. Though it is 10 in this case, but it is A now. Even if you wish, you can delete 10, no issue, doesn't matter. I put dimensions here because for reference only. For example, this is 35. This is only for me here, but it is 3.5. When I take into measurement, I don't use 35. I take in relation to this dimension. This is 10, or it can be whatever. When I say this is 35, so for purpose of transferring it to cell, it is 35 divided by 10. I take 3.5 or whatever value A is. So I convert this value into same pattern, this dimension or this dimension, whatever dimension is there, that works like that. That is one part of this, very important part, because that will decide how dimension is, how it works, So that is one part here. But another part is circular part. See, this is also not clear, means she's saying is, you can say diagonally or something, and this circular is meeting here, interfacing with this rectangle is interfacing with this circle. Then, this angle is 180, and whole circle is 360, but this is not complete. This is a kind of semicircle here and part of a circle. So in that case, we know radii can be measured, that's not a big issue. If it is a regular circle, or you can say circle is regular always, if it's not even, you can measure this curves and diameter, radius can be measured. So I use this angle here because I terminated this rectangle here. So here this line to this center of circle, how much is that? So we can check it by angle here, included angle here, or whatever you can say, included angle you can call it, or whatever angle. This angle is clear that this is 180. So this is semicircle, but this is 56-degree circle or sector you can say, or 56-degree you may say, whatever you can call it. This is 360 is one circle, 180 is half circle, and this is 56. So I use this angle. So this angle, when I use this angle, I put this in that same form as A. And then here also area 1 I take this I take area 1, then I take this area 2, and because I use this area as 1, so that I can use formula of semicircle for purpose of area as well as for purpose of circumference. So this circumference has to be calculated for this measurement. This is to be calculated. Parameter for straight. This is parameter here. You can see this? Yeah, I think one line is missing here. One something is missing, so it is here. You can say it's here. It's missing actually. Oh, this is here. You can see it's right now. And this measurement is also clear. Means this is some measurement, and this is half. Let me see how much is that. It was put somewhere, maybe I don't know, but whatever measurement is here, it's 4.6 ounce written somewhere. If not written, we can write, that's not a big deal. And how much is this? You can say how much is this? We can say this is, for example, this is 20, right? And this is here. You can say this way or that way. You can take everything's right. So this is 4.69. This is okay. This is 20, and so this is 2A. You can say rather than 20, we can say okay, this is 2A. We change 20 and we can take 2A for our convenience. So it is 2A, right? This is written 2A. We can say, we can remove this. This is 2A. This is right. If you wish that way, no problem. So we remove this E and this is 2A. It is khalas. And this is here 4.69. So this is 0.46. You can divide by that. So there's no space to write that one, so I leave it as it is now. And only for explanation purpose it is. And so this is our pattern in this. This we calculate here, and this we calculate here, area 2, area 1. Area 1, there are two ways to calculate this. You take this radius and find semicircle area, and you can take this radius and find semicircle area, and then this area minus this area can be this one. Or you can take mid arc and average width is this whatever, and you can see that it comes both ways, same value. So 1 and 2. Stay. In this case, we will take quarter. You can say we can take either 90 degrees or you can say half. Whatever degree let us take, we take it. Half 180. If we take 180, semicircle first. And then we can multiply that formula of semicircle by 56, multiplied by 56 over 180. Or we take, we take quadrant formula, then we can, that formula is, 1 over 4 or 1 over half. If the semicircle is 1 over half into 1 over half, 1 over 2 into pi r, pi r, and then pi r, semicircle is pi is whole, so pi r into 56 over 180. Or we can say half pi r into 56 over 90. So we can calculate 1 and 2 as we wish. Then for circumference as well as for area, we use that one. In this case, now problem here, this is not rectangle, this is trapezium. So for trapezium, we should know these values and these values, and then we know this one. We measure this one and convert to A. And we measure this one, so for example 35, 3.5, if it is 10, and 40.31 shall be taken 4.031 A. So this knows the problem, so we can take sum of these two and half of these two and multiply by this. We can get area of this trapezium. Of course, you can take this plus this for purpose of this, and then we have this. Same way, this is the trapezium here. Area 4 is the trapezium. This we know because we know this, so this is known. This plus this we know, and this we know. And then we can say A here, half of these two sums, these two dimensions, and this we can get value of this trapezium. Either we take this trapezium, or if we take this trapezium, then we can take this as rectangle. Similarly, if you go further, this is 2, 8 by 5, and this dimension here, 25, 20, and R15. This radius is 25 from here to here, or here to here, or 15 here to there. So this is that one. I think it's scalar, right? Maybe you know what I'm talking of right now. There's something else. Now, a problem comes on this letter 3, which is, it looks that it is a little complicated. Letter 3. You can see this. You can see this. In this letter now, this is neither circle but part of the circle, and this is, you can say, we have taken this semicircle here. First I put whole circle, and then I put whole circle here, and then divide it accordingly. So this is semicircle here, and then from here to here is different measurement. From here to here, this is area A, and this is then area 2. Means one is semicircle, and other is remaining one, whatever is that. And that is actually very problematic to find. And I'm just going to tell what I did in that case, because symmetrical is this side, and here you can say this 15, 20, and 25, okay, fine. But there's even one clash here in this case. This also is okay, mid of this. You know how we have taken this. This is 3 here, I taken this one. You can take extend up to here if you wish, doesn't matter. I just took it in different way. And now, because I put here, center to this, as you think like this, if you see this one here, XL, V. If you say like this, I just put half, just here I put. So this is quadrant. Means it's not necessary to take this one. I have taken for my convenience like this. So this point I took up to middle of this. Now, what is that actually? There is you see this line, and there is a curve here. This actually was coming to here. So what I did, I just cut here at this curve, because both curves are coming from opposite direction to each other. This is coming this way, and this is coming this way. So this interaction here, interconnection of these two curves, and I held it at that curve and put like this. Now, area, because we are finding this area, and then we have to find this area. We have to find this area, this one area also, because this area is a trouble one. This area, this is a big trouble, because when you find perimeter, circumference which goes here and then cut off there, it doesn't go in. It doesn't go in. Similarly, it has to stop here, and we have to go, after reaching here, we have to go to that place again. So we have this area impacts on area as well as circumference. That's where we have to understand. This angle we have here include the angle, or it includes the angle here which worked out here. You will see this geometry here, this geometry here, because this and other part are same. So there's no space to find angle. I use this space to find angle. It's like this, this curve is meeting here in different positions on these 3 circles. There are certain connection points here, connection point here, and there's another point here. So these angles at this center point, I worked out through this drawing that 33, 34, and 37. So 3 sums are 35 average. Now 37 is this, and then you can say 37, other one is 34, and actually it is showing 34, but he should say it is 33. Now in this case, this portion as area, this portion as area is a question one. how to calculate area of this, because we cannot consider triangle either, we cannot consider as a triangle also, because if you take triangle, I say approximately, or let us consider this. I can say, okay, let us take it as a triangle. But I was not convinced with this proposition, because this is quite considerable area. So we cannot consider as a triangle. So I said, no, we don't want triangle here. We have to calculate the real area of this. And you know that every curve is not actually real curve, it's a part of lines. So what I did in this case, I divided this distance from here to here, this distance here to here, into 2 meter intervals. That is to say, one line is here, other one is here at 2 meters, then other one is here 2 meters offset, then 2 meter offset, then 2 meter offset, then 2 meter offset, then 2 meter offset. So whatever balance is there, and it is symmetrical on other side. Then because we can measure straight line, 2 meters will not make much difference. I mean, it is just near same area as if you calculate by curve. I try to make mixed, I try to convert these lines. For example, I join these lines and I noted that on this curve, on this real curve, and my lines approximately are same, is maybe 0.001 millimeter difference. But if you want to take 1 meter difference, you can take 1 meter also. It is not necessary that you use 2 meters. You can take 1, and 1 like this. So it will be better, it is more accurate. It's up to you. Then I can find these distances. This distance is how much? For example, this is this one. Then you put other one, then this one, this one, this one, and this one, and this one. So this is then a kind of a triangle approximately, because very little difference. So you can say we can consider this as a triangle. And others are trapeziums, this dimension, this dimension, this dimension, this dimension, and we can use this as trapezium, and then we can double it. Though it's little difficult, because you have to use how many trapeziums in one cell? One triangle, second trapezium, third trapezium, 1, 2, 3, 4, 5, 6 trapeziums, and one triangle. 7 figures you have to collect in one cell. It's not difficult. You can take 50 even, but for everyone it's not easy. That's the purpose of this. So when I take this angles calculation of 37 or 34, 33, because it's 3 points here, there also. So we have to, I use the average of these three, that is 35. And then because I'm taking that angle, I'm going to take that angle, and this is here. I think that angle, we have to see this area as well. That's why I put number 1, number 2, and this is number 4. So my angle measurement is up to here. So this one is to be calculated separately, area 4, and then I consider 5 is independent here. This is not independent here, area 4 means little different. I should say, okay, I take this again, in place of 2, this does. You can say, in place of, this is 4, and this is 4. Of 2 and 6 here together, and you can say 1 and 7 here together, and 5 is independent, and you can say this is 3 and this is 4. So it is 1, 2, 3, 4, 5, 6, and 7. You got my point or no? This is 50 and this is 80. 5A, 8A and 5A. And we know this radii. So we can calculate this, or we can calculate this, or we can calculate this. We can calculate geometrically all this. And we can say, okay, we take, means when we take half of this semicircle, and according to angle, this is the other one. And we can use this also separately, and we can resolve this real 3, call it real 3. When I talk on on worksheet. I thought to talk today, but before that I thought that I should involve you with how these figures, how these diagrams or letters are worked out or drawn, and then measurements are taken from there, and these are copied from here and pasted on Excel formula. So this is 3. I think you are getting my point. I think you are getting my point. There should be no problem in this because it's a little complicated, of course, but it's not very impossible, you can say. Isn't impossible. You may say that, but it's not impossible. Now I say, okay, we go to 4, which is, is not very difficult. I just put parameters, dimensions here, A, which is this one, 3A, which is this one, total is 8A, this is 3A, this is 5, 3A, 4A, and this is, I think 4A it is, because I did not write that. I don't know why, but let's say this is 3A and this can be 4A. So this is 4A here, you can see in vertical position. So we can say, okay, this is 4A. So this is 3A, this is 4A, and this is 3A, and this is 4A, this is 3A, and this is 4A, this is 5A. So all dimensions are clear, and we are going to use this unit dimension here, that is, here. So it is, then you can easily say these areas are 1, 2, 3, 4, 1, 2, 3 only, because others are measurements. When we call these are measurements, actually A measurement, 3A, 8A measurement, like this. So I think you got my point. No, I use very ordinary 4. You can use it like that. Means from here you can take out and go like this. It's up to you. It's not necessary for me. Means what I mean, what I mean is that if you take it like this, means here like that, it's no problem to me. You can make your way. It's just up to how you design that. It may be like 1 or something you can take and join this one. So that's not a big problem. You can take another area in that. Now this is for, now it is very easy. Even parameters can be continuously taken, just like areas are taken. Now comes a different figure now. That is this one. It is really little difficult because we have to fix in same area, as I said, 5A this way and 8A this way. 5A and 8A we have to use real, see always real figure is difficult one. Rectangular like this or you can say like this is not a big issue. But these are really artistic figures, and 6, 5, 6 for example, 7, 8, 9 and 0. These are worrisome, concernable figures. And 5 of course is, so what I did then, this portion is circular, of course part circular. You draw circle here, and then according to what we get here, we can construct like this. You can see this is a little different shape. Here you have to give 4 I have taken here, and up to from here to here is 5A. And I cut something here, you can say how much I have taken this, that's the one that you can say. For example, if you say this, how much I have taken. Either we can take this way or that way, it doesn't matter. So I can say, okay, I can take this way, no problem. Just to show you how I can say, okay, this was here. So what I say, here's node hand, we can say, perpendicular here. So how is that, How is that? It is A. It is A, you can say. So it is 10. So it is A. So we can say, I have used this figure A. It means from here to here is A. That's what it says. This is A. This from here to here A. I did not put this line because of so many issues. It doesn't take much memory. Objects are counted here and we have to use those only. I take it out so that it increases unnecessary memory, it increases, and it's now here. So this is 4a, this is a, and this is different, Probably it is 3a. Let us see how much is this. I can say, let us count how much is this. Okay, I'll say from here I can take and I'll see how what's position of this. It is horizontal. It is here. Hold on. How much is that? Let's say di, and this is from here to here. Vertical position is, so it is y axis is 10, or no, x axis is 10, y is 30 something, 32 something. This is coming because of varying dimension. Now this a, put fix a here, and there's nothing this end of this. We can say, got my point. Let us draw again and see how it works. Let's draw another one again and see how it works. Let us say vertical line here, and then we can say, okay, with another line here, which was a before. Is a before, now it's not a, so it's a. So how much is that? We can check it. It is di. It will come as how much, and point, and this is the R. So it is, yours is 32.4499 or 32.45 is that one. So we got this dimension as well. Just for your reference, I'm telling how can we do it. No need of showing everything here because I can't abuse memory. And we connected this point at this point. How it got it, that's just a point here. In that case, we say, when I reach there in this curve, I got center point here. So I put angle 75 here for this construction, and we took some point here down and then offset 10 here. This is fixed point A is there. From here, the offset here, and we got this equal to A here, and we got this. We got my point, and I think this is excessive dimension here. I believe I remove this dimension. So this is here, or you can say what maybe some other point it was. From here to here is from here, somewhere here. So this is nothing to do with this as well. And here I say this is A, this is A. So we got this point, absorbed this point, and then I took this dimension here tangent to this one. At this point tangent, put here near tangent, so we got this profile, and offset we got this profile. So phi was constructed. There was no problem on this. So we have this dimension, we have this dimension. We can convert it to A, and we have this dimension also A, and then we start here. Means we can do offsetting here, and of course this is constructed, and then we have this dimension with us, this dimension with us, this dimension with us, this with us, this with us, and of course this R is there. So we got all these 1, 2, 3, 4, 5 areas worked out in dimensions. So it's not an issue now. It's not an issue now. And we can, of course, there will be two issues. One is rectangular trapezium, up to this point, 1, 2, and 3. Then 4 is not, is curve 1, 4 and 5. So separate calculations on same formula required to be affected. Then we go to next one, and that is again curve 1, that's 6. Yeah, one more thing about this. I think I didn't tell you about 3. This area has to be worked out according to requirement. Here also that area, that type of area doesn't exist. There's a simple barricade for a recording. So we have trapezium here. We have another trapezium here. This way, or you can say this way as you wish. If you can take this up line here and calculate the second one, and third can be in that case rectangle, or you can take up to here also. It doesn't make a difference because this can be 2 and this can be 3, or this can be a trapezium, this can be a trapezium to here, and this can be a rectangle. It doesn't matter, you take whatever way. And this is curved portion of 4 in this portion of 75 only, and then semicircular area 5. And after that we have to find parameter, which is this one, from here to here and here to here. This is not worked out. So this is 1, 2, 3, 4, 5, 6, 7. There is a circumference, this circumference, and this circumference. Now 6. Yes, it's also a little tedious. 6, because it's one end is circular, and other end is semicircular, and then there's trapezium here with complications. You can see here complications here. Complication of what? It's easy to draw circle here, no problem. It is easy to draw semicircle here, circle here, and then you can say trim it, right? Here is neither a trapezium. It's something different. Means trapezium and combination of this arc. This is very important. We are going to use this curved portion. This curved portion is very different. This is very easy. We can draw, and we can say this also we can draw. But here again same, we have to apply in this point and at this point. This point, when we come, we say this point stemmed and line is drawn, which I meet. Same thing here with tangent one. We join these 2 points. We join these 2 points. However we join, it's up to us. Actually, we put this line up to here, but because there's nothing as such here, we can say, if you wish, you can join from here to here. It's not a big issue. We can join as we wish, but it should be clear. So if I walk here up to this because of that, but if you wish, we can take up to here, but because we are dealing with this only, that point is very clear. Here, if you can't see, maybe you can say, what angle is this from here to here? And this is tangential here. This line, this is tangential here, and this line is tangential here. So had we taken this way also differently, it would make little difference, not much difference. So you can say, okay, it's like that. And we take different positions here. So that's up to us. This area requires adjustment. That's very important. If required, I'll correct this diagram. I'll require, but for this procedure, I'm just telling you is this, that this area is workable. Area 2 is workable like this, trapezium, and adjustment of this. What we have to do, we have to measure this trapezium and then deduct from this portion of arc. It has to go from this one time it has to go from either this or this. So it depends upon how we take it. This area 1, this is area 2, and I take this is area 3. So from 2 I can deduct 3, or from this I can deduct 3. This area has to go. And then we have 4, which we say whole area here is this direction of this minus this. Or if we can take angle, not a big issue. We cannot count, when we say angle here, we have to take full area and adjust this angle. This angle is from here to here. We have to in circumference, we have to deduct this. This portion cannot be taken as part of circumference. When we join this, means this portion has to go from late activity, delete activity. We have to do that. You got my point. Same here, we can raise many points ourselves and use this for different purpose here. And then we can say, you know, if I can say I want to change it, you can change it also, no problem. Means I can change it like this and it would work, no problem at all. I'll do it, no problem. Now, I think you got what I say. My purpose is to just apprise you of what is being done, how it is being done. That is important. Sometimes, I draw many sketches same time. There can be some error in some and there can be something else, but that is editable. Now, this is 7. 7 is not very complicated but it is complicated as well, but not that much. Because there's no curve in this. It's all right. There's no curve in this. I think. No, this is 5 and this is 8. If you want dimensions, you could put dimensions, no problem. So you have done like this and you have done like this. All is okay. Means now if you can see this portion, this is there, and this I took 2, and this I took 1. 2 here and half here. What is this? 6.97, because it depends on how these halves are struck. In this case, this is this A, 5A, 2A, and this will come according to this value. Means when we connect here, one leaving A behind, we connect this will be formed, and then this will match it plus. Drawing wise, this is not difficult to construct. Now we have to define areas here as well, because this is 1, this is 2, both are not difficult. This is full area, rectangular, and this is trapezium type area, and this also is a trapezium here, and we can see this whole area is trapezium plus this triangle both. This is A, but this is not A, this is less than A. This is 3, yes, 3.03, which is 0.303A. And these measurements are the actual measurements, and you see 72.11, which is 7.211A. Got a point. Wherever it's coming means we have to convert to this. So you got this point, right? And we can convert all these dimensions in terms of A, whether this dimension or this dimensions. So it is only for purpose indication. Means if I say no, I don't use this A, it's different dimensions. So but proportion of A and 7.2 shall remain same. When I say no, this is 5A, this is 4A, this is 7.2118 because 72.11. So you can say 7.211A, and this is 3.03A. So it is so that's 8 now. Eight. Sometimes it's not so easy. It's difficult sometimes easy. It depends on you what you think about that. So it is 25 and 15, circle here and circle here. And there's interconnection between two. This is, symmetrical. We know 8 is symmetrical. Yes, there could be different. We want to take shifted it here. I take symmetrical one. Some people use this and then this, this is smaller radius. It could be say, and it's R15, it could be R10, and then not. It's different than R10 and 15. Then it could be R10 and 15, R10 and 15, 25. Don't I think? Yeah. So, but as far as this easy one, we take equal, and then when these two meet, we have to design this area, drive this area, how to reach this. That's the point here. And it's not a difficult one in this case because we have radar dimension and we have these figures here, this triangular figure and this rectangular figure is automatically common to these two areas. This area 3 is common to these, this rectangle is common to all, and this triangle and this triangle are common to both sides, both ends. We can measure them from dimensions and use them in terms of A. Here, this angle is important. Yes, this incident angle. This is important here for dealing with this part of area. Dealing with this part of area. It's very important in this case. So area 1, area 2, this triangle, area 3, this middle rectangle, and this area 4. And then 5. 1 and 5. When we calculate them in Excel, this is the clear to us. 9. It's inverse of 6 actually, it's actually it's reversal of that. 9.
खाली खराब जाएंगे
क्या है?
गुलाब जामुन
So you got me? Do you want to eat gulab jamun? Area 9. Area 9. Here I met these 2 points correctly. So this will be same there. Got it? I will correct that one. I think there's some error in this, but this is not error. This is okay. You can see this point and this point. These 2 points tangential here. This is tangential there. This is tangential. This one. This tangential. This tangential. And there's a connection of these points. So that is not a problem. Purpose of this is to acquaint you with what is done. That's important. Not values. It's like like algebra. We are doing algebraic exercise. This circle, this circle strip, both are strips, circular strips and lesser circular strips. This is full circle. I drew by full circle, but I adjusted that one, and this is part of semicircle. So we call it part semicircle. You see, 1, 2, 3, 4, 5, and 6. triangle. 2, 2, 2, 2, 2, and whatever remaining there, which could be anything. Yeah. Right. These are measured, These are 2, 2, 2. Area 1, area are there. Area, this is A, this is 1, this is we know, and this is 2, this is area 2 here, this one area 2, this is area 3. This oval has to be found out, and this area has to be deducted from this. This area has to deduct from it this area. I have given a number to this. 1, 2, 3. Know that? On this angle, you see what we have to see means how much is that. Example, that it is now example you can say here. You see this? Outside is 210. So what is inside? 150. You can see this. This is 150. I can say little down is to 10, 150. So total is 180, and this is 30 here. This is 30, right? So we can find area from this semicircle out. When you calculate the semicircle here, we can rather multiply that semicircle area into 150 or 180, and we can find value of that. And also these trapeziums here, one triangle, trapezium 1, trapezium 2, trapezium 3, trapezium 4, and 5, and 6, and 7, and 8. How many are there? We have to calculate all trapeziums and triangles and work out this area. And from this area, we have to deduct this area, and we can find that one. It's not big deal. I think you got my point. And when we go from here to 0, it's not very difficult, but what circular point works there? That's the important one. Circular points works there. In this case, you can say we have semicircle here, we have semicircle here, and we have rectangle here. So we can put area 1, area 2, area 3, area 4, area 2 and 4 are similar, area 1 and 2 are 1, 3 are similar. Dimensions are here, it's not big deal. So we have A here, and we can say that, okay, we are able to work that way. You got my point. So when we discuss on Excel worksheet, we'll see how it works. We can probably tomorrow do that, because this area is easy to calculate. This area is easy to calculate. These are rectangles, and also combination of rectangle and rectangular. You can see this is perimeter, this is circumferences. We will work accordingly. And this will be checked in how it is there. We will see how does it work. Now this is this one. Let's see other one. This is here. Now that was a circular as well as this, but now this is also different shapes. We take both shapes together just to see, because sometimes we do not want to use curve. We want to, okay, we take 2 like this, right? Or we take 3 like this. Means in it's different way. It depends, And 6 like that, 8 like this, and 9 like this, and 0 like this. See, we opt for that. It's not necessary that we do only this. There are many propositions, and here it was done. Actually, there was some problem with that, so no problem. It's what the same thing. It's now this we have already discussed. Now discuss this one, right? So now this is happens. We have to adjust how to draw this. Try to keep these dimensions the same, and we have to divide. We use this strip on center of this height or depth. We can say x-axis, the y-axis here. Then we have the 1, 2, 3, 4, 5 strips of A, which is symmetrical on both sides. So areas can be worked out by this dimension, which is 5A to 5 by A, and this is 2.5A by A, and this is, saying this is this dimension and this dimension, and here is this dimension, this, and this is this dimension. So same way parameters can be worked out, and it can be this. Okay, then we come to 3. 3 also easy, means just something here, and we know this is 2.5, this is 4, and this is because 3 are 1 there, so 8 minus 3, 5, this is 2.5, the 4, and this is 2, I think, probably. This is 2, let's see how much is this. This is, yes, it is 2 and 1. So 1 area, 2 area as a whole, 3 area, 4 area, and then we can find all that. That's not a big deal. So we can do 2, 6. It's also rectangular, and it's also, it's easy. Areas are there, dimensions are there, everything is there. We can find 1, 2, 3, this or this, whatever, 3, 4, or this one, and 4, 5. And parameters are clear, external in this case and internal here both, because here external and internal both apply. This is whole external. I mean to say this whole is external, and this is internal. So it's not a big issue then. 8, 8 is now we are taking not different sizes. We are taking hair one size and upper circuit another size. A little difference, squeezed one. Equals 0.5 A here, 4A here, so this is 5A. So we reduce by 1A here, so half and half is here, and 1, 2, 3, 4, 5, 6, and 7. 8A and 5A. 5A and 4A, this means this is half this half this. So this is vertical, but it goes to 3.5A here and 4.5A here. So the difference of A has come in. And you can say, okay, these dimensions we know now. It's not difficult to find area as well as parameters and internal parameter as well as external parameter. Both are workable. 9. It means just like we did 6, we did 6. Same way we have 9. It's not as very difficult, and 0 is also easier. You have internal here and down here, and you can say this is okay, fine, and here is what I say. As I did before, I think I discussed it. No, not, I don't remember. B, C, D, G, B, A, and all these things we discussed, right? Let's have a look on A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, and also this with curve here. It's difficult to see A, how C is before B, how it is. It's A and B here. Let us see, other one is geometrical shape like this, and then geometry like that, and then there's this one. So let us see one by one these drawings, because these drawings are very useful in working out parameters of area and parameters as well as circumference. That's what's required here. So let's see one by one. Of course, with some patience. It's with some patience, and you can say how it is. Hold on for a minute. Maybe you can read this. And just keep 1 minute, please. हाँ? कुछ नहीं गिराया, कुर्सी खींची थी पीछे, कुर्सी खींचते उसकी आवाज है। अब यार जाम हो जाते हैं ना। to stretch my legs is necessary. You have seen this before also, you might have seen this. Again, no problem. I show these dimensions 8 by 5. Then also here equal. Just put one here, you can say division here. You can 3 here and 5 here. So this is 3 inside and this is 3 inside here as well. And A is unit of measurement, so it's no problem at all. Then you can see B as well. J offset here of A, if you consider from here, is an offset of A. And you can say pattern is similar. And dimensioning, only this is different. But you can see areas are clearly demarcated. And A is mentioned here. So it's not a difficult one. And C is very easy. You know, it's seen very easy, not difficult. D is a question here because of this bevel edge, taper edge. You know, we have to find this and we have to find this. Angle is of 45, 68 here and 45 here. This is, you know, you can say what angle. This is, you know, we have to understand each and everything here. I say this one is here something, and then you have to find out these dimensions and these dimensions, and then area 4 is this. This is area 4, this and this is area 4, which you have to find. This triangle we have to include in this, or you can do a triangle. All these 4 triangles are equal, and then we can same thing. Whatever we got here, and then E, which is of course very easy because we understand everything now, and of course F, you know. If you know E, it's not a problem. And then G, like this. This means it can go as it is, and H, of course, very easy, and I, you know. Similarly, you can see if you take, now question is for B here because this is now in different mode, in this mode. This is question here, which you have to do, you know, as we explained to you. This offset here because this is you know 38.5, and that is something like, you know, different on this 28.5 here, and there's a 10 difference here, so it's that one because of this. And C, you know, we have already discussed only this semicircle part. We have to deal separately, and this is square part here. And similarly D, you can see D is like this, and these 2 quadrants here, which you have to work out, and this is quadrant, and then these are, you can take this straight or you can take this where is you want, and then only this 1, 2, 3, 5 are no issues. These 2 are issues you have to understand. And then you can say G, of course. G, that is, you know, here is 1 and here's 1. 1 is, this is quadrant, 1/4 of a circle, and this is 1/2 of a circle. So similarly, we can work out this, and we have done it before. So then you can say the J, K, L, M, N, O, P, Q, R. We have already discussed. Now, not big deal here. So we can say, now we say, this is, we have to go to the S we left here. From there we have to go further one. And S, if you take ordinary case, here, then this is S, you know. In easy way, in square pattern, you have to do like this when you are doing a square. So area 1, area 2, area 3, area 4, area 5. And dimensions are similar, 2.5, 2.5. This is symmetrical, It won't cause a problem. P also is something very easy. Once you understand, means, and then U also like that. V is difficult, a little difficult, because it's inclined. We have to work on trapezium here and on triangle here, and trapezium here and triangle here, and these dimensions we have to check from drawing and convert them. So this trapezium and this trapezium, as well as this isosceles triangle possibly, which are not very difficult. Then you can say W, of course, is similar. It's very simple. 1, 2, 3, 4, like this, and you're getting. So this then butterfly X, you can say butterfly X, like butterfly basically. So areas are more or less similar. It's easy, and Y and Z. Z, of course, you have to work out here in this case. You have to establish its direct roles, though it's not squarish exactly, but because it is a rectangle, this is a trapezium, and this is a trapezium, and this is a trapezium, and this is a rectangle. So it isn't very difficult. Now, question comes into S. This is what we have to think of, how to do it, what to do about this. Because I want to limit this video to some times. It's just 1 hour and a quarter now. And just watch what this. You see, read it. This, how it has been modeled here, how it's been drawn. Its point here. It says here is semicircle, and here is semicircle. You can see this. When you appear in driving test in Gulf somewhere, you can say that there's a box here, and there's a box here. Though there's only one box, but I'm just saying. So you are driving this way, reverse. If you are driving reverse, you are going to get bollards here, some traffic bollards here, and all bollards are here, all way, and going like this, and bollards, etc. So you drive back. Gradually, slowly, you come like this, go like that, go like this, go like that, go like this, and here this, as you can say, some box here possibly, but let us say this is the harbor. So this is that, what I'm saying, S, they call it S, that trial diagram, driving test trial diagram, driving trial diagram. So this is, we have to work out, first of all, we have to draw this as a diamond. 22.5 is draw. 22.5 is 45 actually it is. So it's from here to here, right? In this case, from here, and for the balance is equal to 7.5, and same here. So we can say area 1, 2, 3, 4, and this parameter is portion. This is parameter. This is semicircle. So where you find this, when you solve this semicircle, only difficulty is that. Otherwise, this is not big deal here. U. You can see what is U about, and this is same radius, semicircle here, and it's rectangle, so it's worth doing nothing, like that. Now it is W. W. Well, it's that easy. No, it's not that easy. Maybe it's difficult for you to even, because so many dimensions are put on. So it's very, I don't use any layers in this because I don't want to use layers, etc. My sheet is not very memorable. It is just a small, 1000 objects can take, so I didn't use that. This diagram itself is communicating something, how we draw W. It's very, not alarming, you can say, but reasonably good, you can say reasonably good, because what you want to do, you have to conceive first. You have to develop in your mind what you want to give. It's not necessary that you draw like this, but there's some concept in mind, and that concept only works when you draw. And it's not necessary what you conceive when you get same one. When you draw, actually you draw, then you find something else in that. And you change it. That's what is here. You see, here it's 9 actually. Let us see how much is that. It's 9A. And this is A, this is A. Strip width is A. I'm keeping strip width A. And this is 9A. Also, we have to use line here, some strip here and bit, which I did not show here, to make these lines, अंदर जाके पूछ लो. So this is W. And we have all measurements here for this diagram. I'm not saying these are for every diagram. These are for only this diagram. We have to know symmetry on this. And this A is everywhere. And we have, because we have A like this, so these dimensions are different. These are not same, these are different. So we have to understand this point, first of all. If you understand this point, we can understand everything. If you just write up, you may not see what exactly is because of dimensions. But we have demarcated areas now. 1, 2, 3, 4, 5. 1 and 5 are same. 2 and 4 are same, and 3 is triangle. This is trapezium. This is trapezium. I don't want to take this as trapezium because this will become unsymmetrical then. So I want to keep symmetry here, and this is also trapezium, and this is same as our. So there's another triangle here. So 5 areas are there, and we have dimensions for everyone, so we can calculate easily. in terms of A, and then you can say that X, is also 9A and 5A. I'm sorry, 9A and 8A. 8A, yes, it is 8A. Let's confirm it is 8A or not. This confirmation is not a problem. So this is, you can say, value, yeah, it's 8A. So I can put 8A if confusion exists then. 8A, And this, I remove this one because this was just put in for purpose of one. And this I remove from here. It's okay. Now, this is very simple in drawing, but in calculation, it's not that simple. Because if it is 90 and 90, it's difficult, this will be no. This will square here in that case, but it's not 90. It's not like this, because 99 by 8. So this here can't be square. It should be rhombus, It's rhombus. Had I taken it 9 by 9 or 8 by 8, then it would be square. Similarly, these are not a 45 angle, no, this is not. So angle is also different. And angle is, 83 is indicating here. This is 7 angle for rhombus, I use rhombus 7 degree here. So it's that one. So the 7 degree vertical angle, and this, then we can say we have one trapezium here, one trapezium here. In one arm, there are 4 arms, There are 4 arms. In one arm, either one trapezium, 2 trapezium, and then 2 trapezium here everywhere. So what we'll do, we have to work up this one, trapezium 2, and add them, and then 4 such cases, and rhombus here. We have already template of rhombus in our worksheet, so we link that one to this one, and we get answers or itari. And also, these are different because of different dimensions. If these were 88 by 8 or 9 by 9, it would be equal, but no, it's not that. So this is okay 10, and yes, we can see. We can work out these two trapezium. So there are 4 such arms and 1 rhombus, and we can find that. So that's what is this. And now it's why this is not complete. I go to complete one because there was some problem in this. And it's dark why. Why? You can see this. It's very, 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 very complicated. Maybe it's difficult for you to read this dimension, but I blow it up and you see yourself now. How does it work? How does it work? That's, let's say, first you see this, because I'm going to blow it up. You may not see all dimensions together. It's for purpose of drawing, we have to understand how we did it. This is the purpose of drawing. Now, in this case, you can see profile like this, and this. 3 profiles. Here we can say this is one. This is, we consider this as triangle, right angle triangle. We consider this as trapezium, and we consider this as, I can say triangle again. Then, of course, this trapezium and these 2 are same. This and this are same, and there is interconnecting trapezium here, small one, small width. This trapezium here, and then there's rectangle here. This rectangle here. So we have what here? We have area A, 1, 2, 3, 4, 5, 6. Yes, see, again I show you. 1, 2, 3, 4, 5, 6, and 7. This is really For dimensions, it means we should know all dimensions here. We should know these dimensions, we should know these dimensions, and we know this dimension here, and these all dimensions we need to find this. So all dimensions are shown in this diagram, like this sketch or figure we call it in this drawing, and you have to convert them into terms of A. That's what is important to know. You have to convert them. That's an important part of this. So dimensions are there. These are not in my controls. These are dimensions of drawing, and I use them only. You can say 8A here and 5A here. But in this case, these dimensions are more important. Like this, like if it's 11.18, I will use at 1.118A because I'm using A as 10. But when you write A5 in your formula, automatically this will be according to the 11.18 divided by 118 divided by 5. Say this is 33.54, so it should be 3.354 or whatever you take, divide by A. So 33.54 is converted to A, which means whatever values they are, that should automatically be operated by this method. So though this looks very complicated, it's not that complicated. You think or I think. We have gone through this already. We have gone through this before. This R, I think you have not. I think maybe you don't go right. I think on that. So you can say this, and also a very important point, and N. M. It was W we talked before, but it's M. You can see this because this is 9 by 8, but this is vertical. This is not inclined in its vertical position here, these two areas. So we try to get it here, a square here. We try to make square here. It's a square. So these dimensions, for example, 14, 14, in terms of the 10. So 1.4, we have to write that one in formula. So this trapezium and this trapezium and this square. This one is to this one and this is to this, and this is independent of both common to two. You can say we can work out all areas, there's no curve in this, and we can say fine, we can manage, we can organize this. Parameter and formula are same, the square formula are same. And this is of course n. You can say we can similarly have divided this into different dimensions and areas, 1, 2, 3. And, we can move ahead with that, not big issue. And here also, you can say these two semicircles. And of course, the steps we have easy approach. I think understand I've seen perimeter area, and this is circumference, and then separate squares and curved areas for purpose of calculations. And then remember this is 25 because this is 50, so this must be 25. And then this is here a bit, this is 40, then this is 20, and this is 30 here. And then P. P is, something really like extraordinary diagram, extraordinary figure, because of its curve, semicircular curve. This is not a problem. This is not a problem. this is something, we can say something, not exactly full problem, but something. So we have to take 50 here, 5 here, so this is 2.5, and half and half. We move like that. So we do not, this is half, this is also half up to here. So this is gone 15 times. So it's not a big deal. It can be done 8:5 ratio. In that case, we can find these areas, this area, and then you can say parameter in this portion, and you can find circumference of this. And then little problematic cube, which is always problematic because it's here. This is I tried to show you on Axel yesterday, but yesterday or the before yesterday, so. But I told you I'll share with you these designs. Right? I'm sharing with you these designs. It's very, very important. It's not necessary you keep Q like this. You can keep like this. You can keep, it's up to you, like that, whatever angle. But I prefer angle this 45 here for this. So that it is easy in calculation from that aspect. Because we have to be very simple in our designs, not complicated one. So we have here 25, 20 and 15, and this 30, and this here, this 30, 3A, and this is 2A, this is A. So strip width is constant, but diagrams are not same. Curves are there, so we have this area rectangular and this area semicircular, either by calculation of middle length or difference of areas of two curves. Whatever way it is done as far as it's right. Now its big problem are because of our we have to work more on this. Let's see which times I opened before, and this I did this. Okay, so this is R. Now we have to concentrate on R. It's really, I cannot say extraordinary, but little time consuming for purpose of trying. You see, first of all, this is very important, in this. You can see that. This is very important. If this is not solved, this portion is not solved, that is area 5 and 6. I named area 5 and 6 because other areas are 1, 2, 3, 4, and 5 and 6. You have to think what I'm going to do. You yourself think, what can I do? I'm going to do. It's an important part of this calculation that I'm going to do, you have to do. Very important one. Because here, first of all, how to think of this time, that's one part. Because the dimension is 5, so we cannot cross more than 25. So from here to here is, if it's 25, it's 50. And we have balance here. So this depends on our dimensioning. And this portion is okay, we can calculate rectangular. This can also be calculated rectangular. This can also be calculated rectangular. But this portion is semicircular, and this portion is neither semicircular, nor neither rectangular, nor trapezium. That's where cause lies in. Now there are so many ways, but I use different way. I use partition that into divisions of 2. which is for me I think is easiest step. We need exact area, and that would come only by cutting that curve into small equal sections. That's where trapeziums are formed, and then these trapeziums can be worked out in calculation, and that's where we are interested in. Just a minute, please. My legs are stiff again. Okay. Uh, this trapezium I'm talking of is most important in this, because this curve is to be deducted from this circumference. This circumference is there up to here. This is a curve, external semicircular curve of this portion 3. But when we take circumference, we'll take up to here, and we have to deduct this. We have to deduct this one, and this is in subtending angle of subtending angle 24 here. This area we have to know, but this is not straight line. This is curve. But just to make it equal to straight line approximately, I partition this into 5 equal. This is whatever is this, this is whatever I put it into divisions, and it is 1, 2, 3, 4, 5. Because the dimensions, one is this, and this 3, 4, 5, 6. Means when you have 5 divisions, you'll get 6 dimensions. Division is 6 dimensions, and because this is A, this width is A, step width, so 2, 2, 2, 2, 2. You can say 2, 2, 2, 2, 2. 1, 2, second, first 2, second 2, third 2, fourth 2, fifth 2. And we have these dimensions here. We can say first trapezium, second trapezium, third trapezium, fourth trapezium, fifth trapezium, using these dimensions up and down and step width over 5, not A over 5. And you can see this area automatically comes in, and this curved arc here becomes approximately what straight line we are taking in pi division. So this is a straight line in fact, and we can say this is considered straight line, and this is considered straight line in virtual part, means not exactly, but because curves are also constituted of straight lines. So we can find this area to some 99.9% approximation. Whereas this circumference, this area, this, hmm? From this circumference, this has to be deducted, right? This has to be deducted from this circumference. And this area is there. So area 1, area 2, area 3, area 4, and this is 5, and this is 6. This is a triangle that can be easily taken. Right triangle. This angle is 40, and we can calculate this out. Con? Con? So this is now, I think you understood what I'm saying. Area 1 is rectangular, 2 is rectangular, 4 is rectangular, 3 is semicircular, and these are trapeziums here. 5 number trapeziums and 1 number right triangle with subtending angle 40 degrees here and 50 degrees here, because two angle sum should be 90 degrees. So 40 plus 50 is 90, and this is the right angle, of course, and we can calculate these areas. But in this curve, shall be calculated based on this subtending angle. This subtending angle, that is 24 in this case, and it shall remain 24 because it's a fixed diagram. So we can say, when we calculate semicircle or whatever we calculate here, let us say semicircle, we calculate pi r, we say this is pi r, that is r is 25. Pi r we calculate pi r minus, you can say, because this is 180 pi r is this, and we have to deduct from this this curve length, and that is equal to how much? Whole curve length is 180 degree. How much is for 24? You got my point? So we can say pi r here minus, pi r, this is pi r circumference of half, semicircular circumference, into you can say 180 minus 24 over 180, right? 180 minus 24 over 180, 180 minus 24, whatever results come in, that divided by 180. So we have proportional, this value goes out of that. We get this value only in this case. So we will get circumference exact one. This is what is important in this, So it is B and D, I have explained to you, and there is 6. All this you have gone through here in this 1 2 3 4 5 6 7 8 9 0. Then this is also square shape of 9. This is also not 9. That is just because I put in 9 here. There was some problem with the other drawing. So I brought that here and put in here 9, and I was getting some same angle is here, and it was all same procedure in this case. And 2, 3, 6, 8. Only those square shapes which were circular there. For example, 8 was circular, 9 was circular, 0 was circular, and 6 was circular, 3 was circular, 2 was circular, and of course this is there. So I just tried to convert them to square shape as well. Then this was a choice, what you want to use. And of course this is just combination of various shapes, and you have seen them before. Just I added this, and then it's y, x, etc. Y also shifted to other drawing because of problem of memory. This is not data which I use, that is different. This is part 1 only. So these are those. Then you can say here, and this is BD, PQR already seen, and here's y actual 1, and this is what. So I'll try to close some of them because of all drawings can't be open. Some of them are closed now. I close them for purpose of it's better. I can't open all drawings simultaneously. It causes memory problem. And let us say that how it works actually, because we are not getting into there's some problem here, Let's close from here then, if there's a problem here. Sometime, if you close from here, if I say, okay, I close from here, close window, and you can say, okay, right. Oh my God. Let's see, first of all, what status of time, 1 hour 49 minutes. Let's say now, we can say, okay, this is Y, and this is MNOP. This is geometrical other figures. This is this one, and here is, let's say, close. We close this. Let's not close. We hang up, I think. Should not hang up. This close up then. Yes, we close this also. So, well, only 3 drawings open now. Just for reference, I keep them open, and I keep this also Y open. Geometry of MNOPQR. I'll try to close it because I may choose some of the drawings to open. So, okay. So I'll see which travel sign is there. I can open more, or let me see if I can. I can't say. I don't know whether I can Excel I can bring here. You won't find that. It's easy, You can't find Excel seen, or it can't be seen. So this means only one format is working here, not 2 formats. 2 formats are not working still. The file is open. This means we go back to close all and then open again. Though because I wanted to show you Excel file, and then I have to stop sharing and it will close. If I stop share, video will close. That's my problem. Well, no problem. That means we continue as we are doing. Let me see what else I can open in this. If I say I am on this drawing. Let me see if I can open something else here, because I did last time many geometries. I showed you last time, I think. I don't know, you need that again. I showed you last time, maybe all of you didn't see that probably, these drawings, and I've shown this back to I think, let's see which else is there. Uh, Real square and Z and shapes here. Yeah, I showed to you this last time, I remember. I showed to you last time also this drawing. Let us see, this is a big drawing, actually old drawing this is, but at that time I was not using this system, this type of diagramming, but actually A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, the swastika and then cruciform, and then some other buildings are there, and these are there. So, but these were only square shape. Again it's written. I written out again because of I calculated the areas and then parameters manually, and then to calculate something else here for other purpose. This is there. So this is something else. Of course, it's same as we did, but exactly it is something else. I put it off. I don't want to confuse you with this, so I put it off. So no problem here. And then, of course, there's something else you can say. Geometry, real square and real square. So we already seen this drawing, and we also seen this drawing. I have shown you many lines. This is what is there in this. Okay, this is something, extraordinary type, you can say. There's a shield here, I worked on that. And this is a star, and this was a swastika in David or in Shakti. It's very complicated in fact. It is, you can say, equilateral triangle superimposed on each other. You can say this way is called male and this way is called female. And swastika is inside male and female here. This means energy is actually some other word I'm talking. It's nothing to do with the engineering drawing. Engineering drawing is this, or you can say other drawings are this. You can say, if you have such diagram with you or such figure with you, you can find area in this, and this is, first of all, this triangle which is full, and then you can impose on that this one, and then you have to deduct this rhombuses from here, this rhombus is from here. Only then you can find exact area of second triangle. The first triangle is full. There's one rhombus here, one rhombus here, one rhombus here. You can see that this rhombus, and these are trapeziums here. And then on this you have to find, then you deduct this one, this one, this one, this one, this one, this one. 1, 2, 3, 4, 5, 6 rhombuses you deduct. So it becomes very, very small quantity, though it looks very big. But it becomes one, and there is a swastika inside, and therefore I wrote Shakti and David on these dimensions for reference only, nothing to do with this figure. And similarly, I put line work of Shakti David. This is a line diagram, and this is also for reference. And here you can see combination of swastika and cruciform. That is, a special kind of consideration. Though it's religious, but my purpose is not for religious. My purpose is for engineering or for construction. Means, there was a building in USA which was of a swastika shape, and they do not recognize, they do not honor swastika. So once they came to know that this swastika, they covered this building. You know that? They covered that building because they think it's omen, bad omen For them it is bad omen. But they do not know this. This for that considered bad omen because of Hitler used this, Hitler used swastika. He used swastika in combination with eagle. Swastika actually is not religious sign. People consider religious. This is something else. Means people say this is religious because of misconception. Swast, you know that. Swast, health. Health, because it's not only physical health, it is financial health and it is other health also. So in our country, or to be very frank, we consider swastika as very pious, very, you can say, honorable or worshipable, though it's something else, but we consider that. We write some line, is like, some say Shubh, Shubh means good or prosperous. It is considered sign of prosperity, sign of health. Some people call it Sati also. And some people consider this as sign of God. There are different considerations, but my thinking is different. If you analyze this figure itself, this figure, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. It is 7, and if you consider otherwise, I don't want to cross this junction. You can say this is a junction here. Still I cross one time here, not second time. If you got me, 1, 2, I crossed it. 1, 2, and then 3. Here I did not cross this way. 1, 2, and 3, 4. So 4 plus 3 is 7. But I don't want to cross it. I say 1 and 2. 1 and 2. 1 and 2. 1 and 2. And I revolve it. I revolve it. So 8 is there. 1, 2, 3, 4, 5, 6, 7, 8. There's 8, right? I want to use this axle move like this in 8 terms. And here is 1 and 2 and 1 and 2, 4. You may say 3, but I say no, 1 here, 1 here, 1 here, 1 here, 4. It can be 3 if you cross it. It is not only 3, but 2, 1 and 2. 1 and 2, 1 and 2, 1 and 2, or it can be 1, 2, 3, 4. So 4, 4, 4, 4. Means it's up to you. It's up to you. So I say, we say 2 and 2, so 2, 2, and in between is 8. 2 and 2. So in fact, 2 and 4 is 8. So 8 is moving around, another 8 inside. This is just, some other way, but simply saying this is swastik or satya. What people say, it doesn't matter. I'm talking of some material, I'm talking of calculation. Our subject is calculation. So this Shakti or this David with having 6 corners, 6 equilateral triangles here, 1, 2, 3, 4, 5, 6 equilateral triangle surrounding 1 hexagon, regular hexagon. 6 triangle and hexagon. So 6 is hexagon and 6 are these corners, and then 8 are these. This is what you have to understand. And then you can say, here I put this. Again, this, so you can say, what do you call it? Star, not star, it's David or Shakti at every corner of it. So this is something else. I try to get 5 also, This is swastika inside, so I develop that figure. Here it is 5, means not 6. This is called star. If you see there's a difference, star is 5 cornered and this David or Shakti is 6 cornered. You see 6 triangles, 6 equilateral triangles, making one middle hexagon, right? And you can say this 360 degree you can say here, and you can say uh, 30, you can say that, what I mean to say, 72 here. I'm saying 72. If you divide 360 by 5, how much you get? 360 division by 5, it is 72. So, if you want 5 corners here, you have to convert this angle 72 into this, and then you can find it. There are so many ways of this, but 72 angle you will form here and 36 here. Because 72 here, 72 here, and 36 here. 72 is 144 and 36 is 180. Triangular measurement of angles is 180. Here is different. You will find, because you are talking of six corners here, 6 corners we are talking, and accordingly there should be same thing. You can say 360 divided by 6, you got 60 here, 60, 60, 60, so that it is equilateral triangle. This is equilateral triangle here, and this is, you can say, here it is isosceles triangle. So we have to work out isosceles triangle solution here, and we have to work out equilateral triangle solution here. And here it is because 5 dimensions, 5 corners, 36 is a 72 here, so we have to work out isosceles triangles here 5 here. Though it's about 2, this is not, if you consider 2 is right angle triangle, otherwise this is 5. And inside is 5 dimensions, 5 sides regular polygon, and there it is 6 sides regular polygon. So 6 corner makes 6 sides and 5 corner makes 5 sides. And if you think there's, I call it a square upon square, you can say. हाँ क्या मिल रहा है हाँ अच्छा अच्छा तो खुराना कर रही हो तो मैं सब साथ वाली बस में अच्छा अच्छा चल क्या हाँ so this is square, this is another square, right? This is a square, this is another square. What do you mean by that? You know, if you see sometimes you go to Gulf countries, GCC countries, to whom you call Islamic countries, though they're not all Islamic, and see their villas or sometimes their walls, you will find this type of morals there, or motif. Not exactly this type, but at least this square over square. And what happens when you do this? So there are 4 dimensions here, 4 dimensions here. Here you are making, one triangle, one triangle, one triangle. This triangle is right angle triangle. Right angle, so this is 45, 45. Right angle, this is right angle, this is right angle, this is right angle. All are right angle. And there are 8. 1, 2, 3, 4, 5. No, 1, 2, 3. And similarly here, 1, 2, 3. And 2 here. So 8 right angle triangle. You know what I mean to say? I mean to say these right angle triangles, we are taking 90 degrees square and then we are taking 90 degrees square. So this is 45 angle here. And this is very important point here. I don't know why somebody is calling, why people are disturbing. This is my always a problem is why people disturb like this. They will disturb my video, I don't know why he's calling, who is this, why he's calling that, I don't know really. Why people disturb, they know I'm talking, I'm a video, but they are calling for what? I don't know reason why he's calling. I don't know this man. Now his video is not coming in, and then it will cut down. See, it's not coming in. I don't know what it says here. What he wants to say, call ended. So there's no meaning, it's just wasting time for what? I don't know any reason. Means signals don't help. People don't understand. They keep on calling. When I'm on video, my files are open. Your signals cannot reach me. And my three drawing files are open. It was 6 or 7 before, and I'm talking, and they just call as if I'm sitting only for them. They don't understand I'm talking live, and it takes memory. It takes memory. Well, no problem. Let them do what I do. People have no business only like this. See? So I was just explaining to you what I did in that. It's this, though you may not have a chance to calculate this in your work, but you should know if it's required, or you may have some other dimension or some other shape. It's one and same thing, you know. It's one and same thing. It doesn't make a problem for something like that. And if I say exactly what I want to see now in E, what drawings I can, although that's the point here. I have many drawings, but sometimes I can't find them. I had some drawings recently. Let's see where can I get these drawings. I don't know, but you know. I had some drawings. I had either to download some. That's downloading is a takes time. My mistake that I was not ready for that. Well, I actually drew some drawing, which is important one, a good one actually, and that was Ranbir House. Hold on. Let me see if I can do something here. 30th November. It's not in this. Let's see other one. Ranbir House. There's some drawings here. Roof beam floor, something. I don't know what's that. Roof floor plan. Well, actually, this drawing is for some building that's existing, and we had something. But since that's something, actually, this is not complete drawing. It's was the old one. No, I close this drawing. Why to waste your time for nothing? It's not complete. So, well, I move on to this. I try to show you this drawing because this is having different type of geometry, and let me see if I can show you something else as well. In this geometry of this another, yes, it's old drawing actually. This is originally we started in this pattern. You can see I started with this square. You remember I started with square, then we shifted to, I think, parallelogram or rhombus. I think we shifted to parallelogram before that, but I don't. Yeah, it's here parallelogram. We shifted to parallelogram, and we worked out on this diagonals and hypotenuse, which is a complicated one. But best thing is in parallelogram, there's no problem for dimensions. And you can say, but when you go rhombus, when we use this angle, so this depth changes. In parallelogram, this doesn't happen. Depth remains constant. Diagonal changes. That's the difference in parallelogram rhombus. You know that. Means this dimensions, height is constant here, whereas in rhombus, height is variable. So it's really interesting to work on rhombus and parallelogram, though, because I was not very styles here. I could have find symmetry and relation between them. And then this is a rectangle diagonal. We worked on equilateral triangle here, and worked on then triangle. This is ABC is given here. We find SA plus B plus C over 2 is equal to S. That is, dimension S has to, we have to deduct A, B, C from S. Either formula is S into S minus A into S minus B into S minus C under root. That's the formula of such a triangle where 3 dimensions are given, no angle is given, only dimensions are given, and we use that formula. S, that's A, S plus B, A plus B plus C over 2, sum of 3 dimensions plus over 2, and we calculate that S in area is under root s into s minus a, s minus b, and s minus c. That's called area of this triangle. And then we can say a plus bc, a plus b plus c is perimeter. Then this is circle, and this is hypotenuse. This we can say perpendicular and right triangle, and this is base. This is hypotenuse, so we can say half into base into height. So easy, and we can find hypotenuse by b square plus p square under root. So that you know very well. So then we tried to convert this this is square and there's a right triangle in that. We worked out on this, and also there's circle and there's a side-based triangles, and we worked out on that, as well as we use this this isosceles triangles, and put one right triangle inside and four right triangle outside, and worked on that. It's all interesting in that case. And then you can say triangle in parallelogram. This triangle in this parallelogram with it, and on top of that we did a later on trapezium here, trapezium, and also then we move to pentagon, regular pentagon. Regular means angles are same inside, and dimensions are same. That is called regular pentagon, means dimensions are same. And then hexagon, where you can say in pentagon angle was 18 here and 36 here, means I can't say exactly, but is this what drawing gave me. And then this is 30, 120 means included angle here, or you can substitute angle with angle here, and this is 108, right? Then we can say this is 108, and this is 18 because 90 plus 18 is 108. Then we went to you can say this hexagon, so we go to 7 dimensions here, 1 2 3 4 5 6 7, and this is 129, this is 39, and various other angles as such, depending on how it is constituted or constructed. And this is your octagon 336 plus 2, and angle is 135, 90 plus 45, and in that case we gone through 9-sided, 1 2 3 4 5 6 7 8 9, and we have worked out this also accurately, because this angle is 140, right? And then other angles were calculated according to this diagram, is based on AutoCAD drawing. And then we can say this 10-sided figure, that's called decagon, and they've used various dimensions, 144 angle here, like this, how these angles are coming, how it happens, 144 how it's coming. So we have to this is what we can calculate. That's not a problem, because we cannot simply say if it's 360, so how much is that? We easily say this 360, and there are 10 sides. This means you understand what I mean. This means you can say, as it is 36 here, so the 10 revolution of 363 by 10 is 36 here. It's like that. Means somewhere we are meeting same thing. Same way you can say, if it is, you can say, though exactly not same, there are different angles, but on an overall basis we use these diagrams for our drawing purpose, so we wanted to construct some regular figure to use, and it is something, roof proportion not doing that one. That's then you can say roof floor beams, which I'll take this later on actually. I don't want to confuse people like this. You can say it's E and geometry. This is geometry. I think this is geometry. Yeah, it is here. So I can say which file I should show you. I'm not able to. Geometry 1. Let me see what was going on. So this is geometry 1 I showed to you. Oh, this is different one, some extension of that. It's, this was okay, fine in this, but here is a different one. Here's an isosceles triangle, and on these three corners of pentagon here. It's pentagon, so this is different one, and therefore you can say that geometry 2, the name is geometry 2, and here, okay, I already discussed with you this, so I close this file because I discussed this one, so I close this file as well. I discussed this one. Now I say no to saving, and we can say open, and then we can see geometry, then geometry again, geometry again, geometry again, geometry 1, geometry 2. I showed to you this 3, 4, so 5. I think you have seen this as well. And there are lettering then, letters, letters and letters, and these are all there. Various letters, square shapes. So these are, I think, this is a good supposition that now I am thinking to extend this, what can I say, this subject, or if I'll try use different type of shapes, or you can say I'll try to possible, in Hindi or Arabic numerals, not numerals, yes, it's 1, 2, 3 in Arabic. I think they're not easy, but I'll see if I can. Meanwhile, I should say that I think it's system only that one should understand, rather than jumping into what I'm doing. It's not necessary you use what I'm doing. I'm just trying to share with you system, means how can we understand to compose or to constitute or formalize this formula, because worksheet is not an ordinary program. It's actually a design program, though people are using in different word. It's a powerful program, and if we can use it properly, mathematics or algebra, or you can say mensuration, or you can say whatever calculation, exponential calculation, or you may say trigonometrical calculation, or combination of these calculations can be affected on such programs. It's really wonderful if we can use them one by one or one by other. I tried only to use something for creativity. It's creativity, mathematical creativity, you can say, or you can say mathematical covers everything. You can say mathematical creativity using worksheet, either Lotus 1, though people don't use Lotus now. They use only MS Excel, which is nothing but a true copy of Lotus 1, 2, 3. Yet, I don't know, in our designs, in structure engineering or somewhere, it is used everywhere in hidden format, because, whatever reason, it's not my business. It's used everywhere in a hidden format, and that's where you can say, something comes out of that, It's not exactly what should be. I think it's not closing because the command is open, so I should say now it's closed, yeah. So, you can see that I try to convert diagrams, because for this I have to draw exact diagrams. I could not assume, because diagrams are diagrams. If you want exact parametric dimensions, you have to use these diagrams. Otherwise, there's no meaning. We cannot approximate something. We cannot do that way. That's not possible. It doesn't work. Next time when I do with you, I'll show you Excel file, And where I stopped last time, it was it's S, and S onwards means there are so many diagrams, so many drawings I have to compose, and of course I have composed them, but you have to get them done, and that's where we have to understand. It's very interesting if we do it rightly, in a good spirit, to learn something, self-learning actually. It's not professional teaching, it's just the self-learning we are doing. Unfortunately, I cannot integrate with this video Excel file or other file, because once you start some form like AutoCAD or drawing, it works in the same way. If I shift to other one, this video will stop. So there's some problem in this online system. So I cannot share with you that file now, but we'll take up, no problem. It's already 8 o'clock at night to 2nd January. So I like to take a leave, but I'll just try to explain what I mean about this simple demonstration. It's nothing to do very, very specific. I'm giving you. It's something that we have to create. Creation is very important. And if you get tools, then you have the combination of drawings and worksheet. Once we create a template, you may call it, or your app you may call it, you can use that whatever number of times until you revise that formula. And if you adjust or revise that formula, okay, fine. Once you learn it, it isn't difficult at all, because it's your own creation, your own device application, and that's for you, and you can make use of it whatever number of times. It's not difficult at all. I have given you something only for your work. If you want to use it further, I tried to post this file, upload this file on script.com, but it failed because generally complicated Excel files, script.com, which is a storage site, doesn't accept. I tried many times also. It just results in oops. It uploaded 100%, but while processing, it didn't do. And so, oops, there's something awesome error. Well, it's not necessary that you use my file. No need. My file is different. Though it's for dissemination of information, because it's not necessary everything is available in text. It's not necessary. It's not necessary Excel books will teach you everything. It's not necessary. You have to think yourself. Once you are educated, you have to think critically. Education means that if you are not able to conceive and think in different way, you cannot move forward. Nobody can move forward. Higher knowledge is required for research work, and research work starts from scratch. It doesn't start from some other works. Some other works, if you research, this doesn't mean anything. So rather than doing some other works, better you start your exponential work in which you are originator of that work. And that is, different type of work where you get value. And in that case, you can do whatever you wish. Probably I will think something else. Maybe I got some idea now or something else. This idea also came instant, means had no plan for this idea at all. Nowhere. I never thought that I would do that. But suddenly I started, okay, let me do something on shapes, because long back I tried to construct something, but I did not succeed based on these letters that I'm sharing with you, A to Z, etc. These are all buildings, but you didn't realize due to some reason of finance or something which does nothing to do with you. But it's not necessary that they should be buildings. For example, I planned something long back, not now, when there was no computer at all. I used to work on tracing paper or on graph papers, big one, these drawings or on drawing sheets, whole long sheets, and using long scale, futta you call it, long scale, and pencil and rubber, just like a manual drafting, just like manual drafting system. I tried to do this with pencil and then ballpoint pen. But in those days, in 92, 93, maybe, this is history now. Still I have those copies with me, original copies with me, and I tried to convert them to something. I'll share with you those files later. I don't know, in this time, I may be having those files, I'm not sure. Maybe in some other computer it be. I'm not sure of those files here, but no problem. A PDF I have. If I could not find all drawing files, I'll share with you. Some files may be there, some may not be there. PDFs are there, and these are actually complexes, building complexes with letter-shaped buildings, many letters, combination of many letters, like you can say, for example, we say that India is a beautiful nation, or we may say something other like Lord Krishna, or anything, whatever you say, like that, which I thought to integrate them in power of national integration, so that we as a country, we having different type of sects and different type of people. Those complexes should reflect them. They should represent them that we are such nation. But that idea could not move because in those days I could not find some promoter. Well, that's different story. But my work is different there, so that I could convert shapes into buildings, like swastik, like cruciform, like ABCD 1, 2, 3, or something like that, which sends a signal of impact to someone. You see, you stand on your roof, higher roof, and see something is written like India a beautiful nation, like Bharat Mata, like Lord Krishna, like Shiva, like such, and we're having different car parkings there in that complex. That was my intention. But everything cannot be converted to reality, because people enjoyed after that. In those days, there was no integrated town planning, integrated complexes didn't exist, and people didn't know about that. Later on, this was added to the National Building Code law. Later on, well, no problem. I don't want to tell all that. That's old, and I was not that fortunate guy to enjoy that success. But success or failure, it doesn't matter. Sometimes we have to move with time and move with something like this. So now it's already 2.5 hours over. So what should I say? I'd like to take your leave and hope to see you once again with my calculation files, and I'd like to add more diagrams if I could. So wish you all best for 2021, though it's very critical year. COVID-19 is moving very fast with variant and strain, and you know what is strain, what's the meaning of strain. If you don't, I'd like to add now. We in engineering use the strain, stresses and strains. Stress is some force applied on something, what is unit of that, how much it is. And strain is change in length, means what original length was. And if there is permanent change, that whatever change is there, that's called strain. So we can say change in length over original length, it's called strain. So that COVID strain is very critical, be careful of that. Or variant also they call it, means variant because it's 70% more powerful. So it's not lower variant, it's higher variant. It may be 200 powerful, it may be 100 powerful, we cannot say. So we have to be very careful about this as citizen of this country and of course citizen of whole world, because this talk is for whole world, not only for this country, for whole world this is. My dear friends, thank you very much for your attention if you are there, or you may view this. I think you may benefit if you view this. It's up to you. Thank you very much, and I close it.